Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate We're now ready to build the third layer on our unit circle. So far, we've built the degrees and the radians. Now we're ready to put all the coordinates on our unit circle. So let's do the first one. The first one should be the easiest. Those are at the 4 spots here. Next, what we're going to do now is we're going to focus only on the first quadrant. And I'm going to show you how we can come up with the coordinates for these 3 angles here. Then, using symmetry and reflections, we can actually take those coordinates and reflect them into all the other quadrants. And the only thing we have to change is the sign. It's pretty cool. So let's start with pi over 4. So what I'm going to do here now is I'm going to mark up my circle here. So if I go to pi over 4, if I draw a reference triangle to pi over 4, there's my angle. Okay, so let's move this a little bit. So let's think about pi over 4 here. So this is pi over 4, which is 45 degrees, right? So if this is a 45 degree angle, then this must also be a 45 degree angle. Okay, so that means we're using the 45, 45, 90 relationship. What do we know about this triangle? Well, we know the hypotenuse is 1 because it's the unit circle. Okay, so if the hypotenuse is 1, then we have to figure out, well, what's the sides have to be? What are those x values going to be? So we have to do a little work. So we're going to use those formulas. The hypotenuse equals something times radical 2, right? Well, because it's the unit circle, we know the hypotenuse is 1. So 1 equals x times radical 2. All right, so we have to solve for x, so divide by radical 2. We get 1 divided by radical 2. Now, if you remember from radicals, we have to rationalize this to get rid of the radical in the denominator. So all you do is take the radical 2 times it by itself, both top and bottom, and we end up with root 2 over 2. So now we know what the side, or what the length of the shorter legs are. It's radical 2 over 2. But remember, this is a 45, 45, 90. That means both of those are exactly the same. So in this triangle, that means the x distance is root 2 over 2. But that means this distance, the vertical distance, is also the same. So this pi over 4 is root 2 over 2. Now let's reflect. Take this over here. This is 3 pi over 4. The coordinates are exactly the same because the triangles can just reflect. See that? So we're going to do the same exact coordinates, but here's the difference. What do you remember about the signs in quadrant 2? X is negative, isn't it? So all you have to do is make x negative. What about the point down here? Again, it's going to have the same exact numbers, root 2 over 2, for both x and y. But what about the signs? Well, any point in quadrant 3 is negative, negative. So make these both negative. Here's the last one right here. So if we take this point, we can reflect down here. Again, it's the same radical 2 over radical 2. But in quadrant 4, x is positive, y is negative. So go positive, negative. And that's it. If you figure out the first one, you know the other ones immediately. Now let's look at pi over 6. So again, we're going to draw a reference triangle. So we're going to connect from the origin to this point and straight down, so make a right triangle. Here's our reference angle. So let's do our scratch work down here. Now, what's my theta? What's my angle? It's 30 degrees, right? 30 degrees, which is pi over 6. Okay. And then we have an x coordinate and we have a y. Now, if this is 30 degrees, that means this one must be 60, because 30 plus 60 is 90, 90 plus 90 is 180. So this is a 30, 60, 90 relationship. So x root 3, 2x. Now, what do we know about this? Well, we know the hypotenuse is 1 because it's the unit circle, and that's the radius of the circle. So the hypotenuse is equal to 2 times whatever the shorter leg is, though. Right? Remember that relationship we just got done doing? But we don't know what the shorter leg is. That means it's 2 times x, right? Well, what's the shorter leg in this case? It's the y side, isn't it? Okay, so h equals 2 times y. But we know what h is. The hypotenuse is 1. So solve for y. Okay, now let's figure out, well, what does this one have to be? Well, that's the longer leg, because see how it's opposite 60? So remember, the longer leg equals whatever the shorter leg is times radical 3. Well, the shorter leg is 1/2. See right there? It's 1/2. So what is this coordinate? Well, what's the x distance here? Radical 3 over 2. What's the vertical distance here? Now, let's use the reflections and the symmetry. So if I take this point here, pi over 6, and reflect it, I get 5 pi over 6. Again, the ordered pair is exactly the same. Let's look at our last angle up here, pi over 3. Represents 60 degrees, so we'll do it up here. So in this case, notice the reference angle is 60 degrees. That means the angle up top here must be 30, because 30 plus 60 is 90, and 90 plus 90 is 180. So again, we're dealing with that 30, 60, 90 relationship. We know the hypotenuse is 1 because it's the unit circle. So again, the hypotenuse is 2 times whatever the shorter leg is. Now, in this case, the shorter leg is opposite 30 degrees, but that's the x distance on the x-axis there, right? Because that's going to be the piece of the triangle sitting on the x-axis. The longer leg, in this case, is going to be the y distance, like that, in our triangle. So what's our hypotenuse? 1 equals 2 times shorter leg. In this case, it's the x spot. If I divide, I get 1/2. Okay, so this is 1/2. Now let's find the vertical distance. Well, that's the longer leg. So the longer leg equals radical 3 times whatever the shorter leg is. So the longer leg is radical 3 times, what's the shorter leg? It's 1/2. So we end up with radical 3 divided by 2. And the longer leg in this case is y. So let's go to our ordered pair now. What's the x distance? 1/2. What's the vertical distance? Root 3 over 2. And it's in quadrant 1, so it's positive, positive. Now we use our symmetry. This point reflects here,